So we heard from Peter there about build systems and the old world of Make that's still carrying on our legacy. And with Waterfall, software releases have been occurring on a quarterly or semi-annual basis. And as a result, builds have been performed by specialized engineers, and that hasn't always occurred on hardware that's been seen as mission critical. And as we come into the Agile era, development has been really influenced pretty heavily by that from the standpoint that we really need repeatable builds that come through quickly and come through in tens, hundreds, or even thousands of times per day. Throughout that entire life cycle. So we're seeing that there is a direct correlation now between the engineering delivery value stream and productivity. Excuse me. And as such, it's important that organizations model their build processes and evaluate key metrics that are driving their performance. Examples there really to drive performance is getting parallelism of the build jobs, building from artifacts versus source, and using quick build techniques. And then also using build pools and leveraging ephemeral resources as well. The build system itself, in old days, have been operated by specialized build engineers. As we go forward, it's really important that this be handed off to development teams themselves, and they be given ownership. Just like any other code, the developers are the ones that know best the application. And it's important that that code be iterated on and be improved in order to gain performance. Allow them to own it, and continue to improve on it. As we go through the best practices at Agile, it's really important that to maintain a green build, either your pipeline sustains either a reversion, as we spoke about earlier on, that we don't check in on a broken build, either automatically revert, or allow a developer a time box to correct that. More sustained modern pipelines will have the notion of a pre-commit check, protecting trunk. But if you aren't quite there at that point in your life cycle of your pipeline, a viable alternative may be that you have that time box window. So as we go through the panel this afternoon, we'll be covering a lot of these best practices. So with that, I'm going to hand over to Bob from Aetna.
Hello. I'm Bob Bates, CIO of Population Health at Aetna in the Active Health Division. And really that's just the care management part that's been pulled out of Aetna, where they do innovation and basically manage the health care for like wellness, et cetera. QMs, ACOs, payer provider. So when you look at what I went into, I've been in this division about 8 months, came from another healthcare company. When you get to move from a few different companies, you get to see like Salesforce.com looks a little bit more like ours than a big portal that you would use, for e-commerce, et cetera, where you're pushing out code every day. So when we walked in, the thing we looked at was, how do I take an organization that couldn't get a build out every quarter, and they were having problems with quality, and say, okay, what is the first thing you do to scale? They wanted to put more features out. They wanted to invest a lot of money. Well, the first thing I look at from experience, and I gleaned the same things you folks have taken and shared today as well, is, what we did was we built basically a model of let's all understand the environments. Let's understand how we get code through the environment. So we built a manifesto, and then we said, okay, in doing that, how do I get code through quickly? And the first place I usually start is, okay, make sure that you have a build process that's understood, and you can do that daily, especially when you're in Agile. Then you do it. You can basically in the development environment, they're doing the builds, and you automate the unit testing, and make sure you have unit testing coverage as well. So you drive quality right up front. And the only way to do, I mean, when we started out, I looked at it, they were doing 5 builds a week. Well, when you're building, when you're growing and you're trying to become an agile team and implementing Scrum and Kanban, you're trying to do, 50 a week, and 5 to 10 a day. And it should be a dress rehearsal from dev all the way through production. I mean, that's the way we've all known to use to implement software. So immediately we identified our environments. If you look at it, basically going through this, continuous integration starts unit testing, and then we make sure we have full code coverage, so we're going through that progression right now. About 50% is automated in unit testing. We have .NET and Unix as well, or Java. ITG, or integrated test, you can call your environment whatever it is, but the first one you do integration or near neighbor or whatever coming out of development or those agile environments. We do a build there, and the developers can see it, but one of the things you're going to hear in the questions when we start talking later is that we take their logins away and say, you can look at it, you own it, but we're going to force you to go through a process. Even if it takes an hour, we're going to make sure that we're doing that dress rehearsal day one, and it's automated, and it's done within hours. And that's basically updated nightly. Then we go through a QA environment, which is more of a regression environment, and those are 2 times per sprint. Actually, we're up to 4 or 5 now, and we'll continue to make those, those are multiple times a day in the QA environment where we can do that. And then you continue on through production. So we're very much agile, but and you have to modify your culture and also the environment that you walk into from a business perspective, the business mandates and the customers. That I heard the same thing. They want code every 3 months. We're actually culturally changing our business model with our customers to get them to take it every 6 weeks, but still that's not pushing code every day. That's not a hot fix. So that's our model, and we've done that, and you're going to see from some of the metrics on the next slide what the benefits are. If you want to grow and scale, build and automation is automation of build and deploy is critical. So when we walked in, we were doing 30 to 50 minutes per build deploy. Our target was 15 minutes. We're actually there, and about 30 to 40% of our applications at the end of the year will be there. If you multiply that by growth of number of teams, I mean, you can't recover that money. So that's how you scale. So that's the first place that we went. And then you tie that with a tool like whatever your CI/DI tool, whether you buy a Jenkins or whoever you use, if you tie automation to that for testing, which we've done in a previous life as well, you can have a smoke test done automated right behind the build and deploy, and you'll know within hours whether it worked or whether you have a problem. If not, you stop, you put developers on the phone, and you start again. And you're continuously updating those automation scripts. And then if you go through those environments, you can see as you get further down, and we all know that, quality starts at the beginning, but it gets more expensive as you get further down. By the time you hit production, those builds, because if you look at the times, that's also stopping and restarting servers, whether logical or physical. We were up to 200-300 minutes. You take that down to 120, and our goal actually for stopping and restarting servers will be far less than that before it's over. So a lot of those goals have been achieved. That's all I've got.
So I think to the question that was on the earlier session of how do you determine the value, this is a good example of that.
Oh yeah, we're pushing from 5 builds a week to 50, 60 a week already, and cutting time in half, and we've already done that.
Great, thanks.
Thank you.
Great, and Andy from Netflix.
Hey, I'm Andy from Netflix. I run delivery engineering at Netflix. And I wanted to kind of set some context that will probably explain my opinion on everything I say throughout this panel, is that continuous delivery is a business imperative at Netflix, and we see it as a competitive advantage. So obviously we are a web site, to use the term someone used earlier, of massive scale, and we believe that we can stay ahead of our competition by putting out new features in front of our customers on a daily basis. So as such, the build system, or the way we look at builds, is actually, we take it up a level, because just talking about compilation is actually quite boring. Builds to us is about, obviously, compilation, but it's about verification, the testing aspect of it, and then the packaging. What is the end result of a build? In our case, it's a Debian file. And so in order for us to facilitate rapid global innovation, i.e. continuous delivery on a daily basis for all teams across Netflix, the build system has to achieve, the build system produces that, that deliverable, that Debian file. It's the basis for continuous delivery. And there's actually a specific pattern within builds that we're taking one step higher that I think is pretty applicable and something you should consider. Is that, to the point earlier, make build files or build systems have been around since the 70s. And they've established a pattern in that's the source of truth for how code is assembled. It's unquestionable, right? In your build file, you delineate what's compiled, what's your source, what is the output, what is tested, how it's tested, and then how it's assembled, what's the end result, i.e. in our case, a Debian file. But at Netflix, we're choosing to look at the build file and take it even higher and say the build file can actually be the realization of how this thing is viewed at the end state. So continuous delivery is a series of steps in our case. It's assembling, but it's also verifying. It's deployment into the cloud. It's running a series of scripts after that. And then we also run canaries like StubHub was talking about earlier. How you canary this particular asset, this Debian, this microservice piece, how do you actually canary it? And then how is it turned live? All those are definitions that many companies choose to define in various systems, whether it be Jenkins or whatever you write. Each of these systems has its own version of the source of truth. In our opinion, all that source of truth should be in your build. So our build files, not only do they describe, again, how you test this and how you assemble it, but also describes how you deploy it across the cloud, i.e. what parts of the globe does this thing go into? How do you verify it when it's in the cloud? What are the functional tests you can run against that? And then how do you canary it? What are the specs on the machines that this app should run on? What are the variances of the various aspects of this, how this machine should run once it's canaried? And then, what are the gates in terms of you define the model? If this canary works, then how do I go live with it? All that is a big definition that meets that meets the definition of a build in our opinion. So that is all being folded into our definition of a build. So at Netflix, we're using a product called Gradle, and we've written our own kind of build layer on top of it called Nebula. And I guess I'll get into some of the details about that as we go through this panel.
Thanks. My name is Germano Labarola. I work for St. Jude Medical, and so I wanted to just explain a little bit of what we do. St. Jude Medical, it's a little different. We're a Class 3 medical device implantable company, pretty much focused on vascular disease, neurological disease, things like that. So what my team needs to focus on primarily is I'm responsible for the neuromodulation part of the business, getting into the cardiac, but not as much yet. So we have a dependency on hardware, quite a bit actually, but my team is responsible for the mobile device portion of it, which is what the clinicians use to program the implantable. And so my focus is mostly on quality because, like you'd mentioned earlier, power of the purse. My boss basically says, need to make sure you deliver, but need to make sure we don't get shut down by the FDA is the main focus. So because of that, I'm not as tightly wound by timelines. Our timelines, our build cycles could be 6 months, a year. It's actually to go from conception to an actual product in 3 years to 4 years is not unheard of for medical devices. Since I'm on the mobile side, I'm trying to add Agile and try to encourage the company to move forward to start adding features that are already available as part of those implantables that we could start releasing out. So I'm trying to get those build cycles a little shorter, maybe 6 months and so on. So what I want to explain more or less from my perspective and what we do for reliability and quality from a build system perspective. So we use a Rational Build Forge, and essentially what that does is it kicks off a bunch of processes. We have, naturally, as most everybody, we have code repository that manages check-ins, check-outs. We also have a quality system that is also tied to that build server that makes sure that particular files that should be in that build are actually in the build, make sure that the appropriate checks and balances have taken place. So the build server will grab everything, quality system, and then we run unit testing and code coverage. Now, all of these tasks that I'm talking about here are gated. So if a unit test fails, that's the end of the line for us. We have to go back in, make a change. The other thing that's also important that has also come up from FDA and one of our deliverables is code coverage. So one of the outputs from our build system is not only just saying, hey, we've run unit testing and the unit testing has passed, because we could say we've run 100% unit testing or let's say 90% unit testing, and that's over the database interaction and has absolutely nothing to do with stimulating a part of the brain. Well, naturally, that unit testing to a large extent is fairly useless. Yeah, it'll cause the application to crash, perhaps, but we may be damaging the patient. So we like to spend most of the time and most of the effort on what we consider most important, obviously, which is and so we have a process of evaluating risk assessment, top-down and bottom-up with FAMICAs and things like that to actually identify components of the code and classify them as either one or A, B, or C. C being the most dangerous, could cause permanent harm. A being essentially your UI layer, which to a large extent is not going to cause any problems. And then B is usually the middle tier, roughly. So once we do the unit testing and the code coverage, then we build the software bundle. Now that software bundle, those assets stay in on a server, or if we decide to deploy them through an MDM or anything else at that point, then we go through a process of build acceptance testing. This right now, unfortunately, I have to confess, is fairly painful. It's about a 4-hour run, and we're in the process of trying to automate that. Now once that passes and it's a go, then we move to test automation. Now, the reason test automation is important is I imagine a lot of you have offshoring testers. We do as well. It helps us maintain a small crew here of active engineers, and then offload the actual testing effort overseas. So that test automation, then that build, like I mentioned, then gets deployed out overseas, and then the test automation starts. There's portions of it that can happen, and then there's portions of it that cannot because they're dependent on robotics and inductive wand placements and things like that that have to happen. So that happens on site over here. Now, once that test automation is passed and we feel fairly confident, then at that point we could ship. But again, I'd say our sprint cycles are a calendar month, and our idea is as well, like I'd heard before, is at the end of the month we should be shippable. Naturally, that can't happen because, unlike many of you, we cannot just release things when we want to. We have to get approval from the FDA or from TÜV or from Japan or China or anybody else.